Hello, scholars, and welcome to our lesson on finding the slope. This is in functions, and this is the second part, where you will now be able to find the slope of a line algebraically using points. Before we did it visual in a graph, now we're going to do it using just coordinates and algebra. Again, the reason we're working so much with functions is because those are most of the relationships we deal with every single day. Remember we ask how much it's going to cost after a process, or how far that car is going to go after this much gas? Those are functions. So the more experience we have in solving those functions, the better we're prepared for our daily living. Let's begin. And we're talking about finding slope algebraically. So we can also find the slope when given just coordinates. This looks like the graph we had before. We're even going to use the same points. But now let's think of them like coordinates. Remember, one point is an xy value. This little one here is not an exponent. It literally just means a first set of x and y values. So this is coordinate 1 is what those ones mean. And this would be considered x2, y2. Again, not powers, but just our second set of x, y values. So we have coordinate 1, coordinates 2. If we're not thinking of it visually, we can also think of rise as finding the difference between 2 points. Remember, going up and down is our y value. So rise over 1 can also be thought of as difference is subtraction. So this rise can also be considered subtraction. y2 as in our second y value minus the first y value. And our run can be considered our x values are what goes left and right. So if we want to find the difference, we can do x2 minus x1, or our second x value minus the first x value. This is just a different way to do the same thing, but now we can do it with just coordinates, no graph. So let's actually do that. We have two different examples here. We're finding the slope of the coordinates of each line below. There was coordinate 1, coordinate 2. Our first step is identify your x1, y1, and your x2, y2. This is very important in the beginning because you can get confused easily if you don't do this. I'm even going to do some color coding. So remember, x is always our first number. So this is x1, and this is x2. X value 1, x value 2. From here, we have our y values are our second number. So we have y1 and y2. We have x1, y1, x2, y2. Our next step is put them into our formula, which is, I'm going to write it again right here. It is y2 minus y1 over x2 minus x1. And I'm just going to plug in what we just said each of these things was. So starting with the y's, we said that y2 is 2. So I'm going to put 2. It's always going to be a minus here. This minus does not change because we're finding the difference. And then my y1, I said, was negative 2. Because there's a minus here, I'll put my negative 2 in a parentheses, just so it doesn't look as confusing. So that is our y values. Let's do our x values now. So again, we're doing x2, which in this case is 0, minus our x1, which is a negative 3. So again, because it's a minus and negative, I'll put in a parentheses. So that is step 2. I have replaced all of these y's and x's with our given values. The next step is to actually do our subtraction. Actually, that's the last step. So if I'm doing my subtraction here, first of all, remember, if we have minus and negative, it simply becomes plus. So 2 plus 2, or 2 minus negative 2, is equal to 4. Over, same thing here. We have minus a negative. That really becomes a plus. So it's really 0 plus 3. So 4 over 3. And that is my slope. I don't need to do anything else. That's it. So it equals 4 over 3. There's no real point in dividing it because it's not going to give me a nice whole number. I'll leave it as a fraction. Let's do that again, because this is kind of complicated. It's good to have multiple examples. Same formula though. So we're gonna look here. I'll start doing my y1 and y2. Remember, our y values are the second number. So y1, y2. Which I could already put in. We had y2 minus y1. So my y2 is negative 5. Minus, again, it's always minus here. Our y1 is negative 3. Now we need to do our x value, the run, which is x2 minus x1. So my x1 is right here. My x2 is right here. If we're doing x2, that is 5, minus our x1 is 0. And just like last time, I now have some subtraction to do. For our rise, our y values, we have a minus and negative again. So it's really plus. It's negative 5 plus 3. Well, negative 5 plus 3, those are different sign addition, meaning I subtract them. 5 minus 3 is 2. The bigger number was negative, though, so it'll say a negative 2. For our run, our x values, it is 5 minus 0. Well, anything minus 0 is just itself. So we get 5. Meaning my final slope is negative 2 over 5, or negative 2/5. With that, pause if you need to get your notes in, but I'm going to clear this up and head to the U-try. Meaning, it's time to see what you know so far. Pause the video to try this problem on your own and resume when you are ready to check your answers. All right, doing that check-in. So remember, you have your y2 minus y1 first. Meaning, you have your y1 here, your y2 here. So if you did negative 4, again, always minus here, and our y1 was 5, then you were doing great so far. From here, you'd have your x2 minus x1. In this case, you have your x1 here, your x2 here. So x2 is 5, minus your x1 is negative 4. If you set this up correctly, then you've done it correct. And our next step and last step is do your subtraction. You would negative 4 minus 5, or a negative 4 and a negative 5 together. So if you put negative 9, you were absolutely correct. From here, you have a 5 minus negative 4. Remember, when you're minusing a negative, it's really a plus. And 5 plus 4 is 9. So 2 ways you could have wrote this. You could have put negative 9 over 9. That could divide to be a whole number answer, though. Negative 9 divided by 9 is also negative 1. Either counts, though. If you did negative 9 over 9, or if you did negative 1, they are both the slope. Let's check the next one. Again, starting with your y2 minus y1. You have your y1 here, your y2 here. So that's 0 for y2 minus your y1 is negative 3. Over, you have your x2 minus x1. And in this case, you have your x1 here, your x2 here. Your x2 is 3. Minus your x1 is negative 3. So you had 0 minus negative 3 and 3 minus negative 3, then you set it up correctly. From here, you have your subtraction. Again, you have a minus and negative. That really becomes plus. And 0 plus 3 is just 3. Same thing here. We have a minus and negative that really becomes plus. And 3 plus 3 is 6. Meaning your final slope should be 3/6. If you like to simplify, you could have also turned this into 1/2. But they do mean the same thing. 3/6 or 1/2 is your slope. This is time to pause and make any corrections if you need to. But I'm going to erase this and head to the closing, which is that we can find the slope of a line algebraically by subtracting the y values and subtracting the x values. So just a different way to find slope instead of just using the graph. With that, I'll see you in some future videos, but goodbye for now.